if I knew the previous one was less, then multiplying by something less than 1 should just make it smaller, right? So you kind of already see this is an induction again. So again, we'll try an induction, but I want you guys to tell me what to do. So what do I start with? I need to start with a base case. What's my base case in this problem? Perfect. See, again, you should pay attention. N equals 1 is not the first step. This is when n equals 2. So we know x is x is less than 1, right? Oh, so which means so what do I do? Well, it's simple. What should I do to prove that x squared is less than x? Yeah, so you multiply both sides by x, and we get x squared is less than 2. Or x, what the hell? Okay, yeah. I don't know what I was thinking. Great, now we go into the inductive hypothesis. I've actually seen some people call this the IHOP, even though this is the worst, whatever. Like when I actually learned this, my teacher called it IHOP. So you do base case, IHOP, and then you prove. I always thought this was weird. But okay. Assume x to the k is less than x for some k. So I have a question. There's a reason I did this problem next. Is this the way I've written it gonna work? Well, let's just try to do the proof, and we'll come back and I'll teach you about something else. But so let's try to do the proof. So we want to show the inductive step. We want to show x to the k plus 1 is less than x, right? So what do we have? We have x is less than 1, and we have x to the k is less than x. All right, so again, I'll box this stuff. Not part of the proof, this is just scratch work. We're putting it on the side so we keep it in mind. So here's where things are tricky. What should we probably do? I mean, what would you want to do? Yeah?
Well, you can say x to the k plus 1 is less than x to the k, so that guarantees.
Well, sure, you could try to do that. But how would you get that from the inequalities we have?
Well, to start with, you can go back to you can show that x to the 3 is less than x to the 2.
Right, so you guys see the problem. It's like what I really want to do to get next to the k plus 1 is multiply by x. But when I do that, I get that this is just x to the k plus 1 less than x to the x squared.
That's the base case.
That is the base. Oh, then we could be done. Fine, we could just use the base case and we'd be done. Fine. That is one way to go, sure. But no, we know this is less than, yeah, we know this is less than x, we're done. So I didn't even think this through, this is actually easy enough. But I actually thought I was gonna have to say is tell you about strong induction, which I don't know if you guys have heard of. So strong induction is a lot like induction. The only difference is right here. You assume, instead of assuming it works for the previous case, you assume it works for all the previous cases. So the way I was thinking of doing it is assume that this is true for all k between 2, or for all k between 2 and some n, and then you do this for n plus 1. Does that make sense? This is called strong induction. It's actually, technically every induction can be done with strong induction and it works. It's just often, it's like shooting a fly with a cannon most of the time. But the idea is just that you assume it works for everything before it. So then, and then when you break something down, you get a case that was previous, but I forgot this was the base case. But we're done, agreed? So life is good. And I mean, and everyone knows that this power of x has to be positive too, right? I mean, if you multiply a positive number by a positive number, it's still positive. We did that k times, it's still positive. Other questions? I've just did two quick proofs of induction. I just wanted to see, are you guys comfortable with those proofs? All right, cool. Now I get to prove a purely analytic problem. I'm going to call this lemma 3. If we have two reals a and b, and I think 0 is less than a less than b, is that right? Probably want that. Yep. Then b to the n minus a to the n is less than or equal to b minus a times n times b to the n minus 1. So now this one's a lot more analytic, but the reason I wanted, he uses this inequality. In fact, if you guys tried to read the proof in the book, he just says, oh, this obviously follows from this other fact, so, and then he uses it. But I wanted to actually go through the proof of this because I actually think it's a nice little analysis proof. So we're going to prove lemma 3 really fast. So I want to show this is less than something. So usually when you start, at least on your scratch word, so we're going to look at this. We're going to start with this because we're going to try to show this is less than something else, until we get to what we want. So when we have a problem like this, the best thing to do is you look at it, you go like, well, what do I know about something like this? I'm just curious, does anybody know anything about a polynomial that looks like this? Yeah? It is positive from what we said before. That's true. But so it is greater than 0, but remember, we want to bound it by stuff. So that's not going to help us very much. But you're right, it is positive. I agree. What? It's not the binomial theorem. The binomial theorem deals with stuff like, 1 plus something to the n. And it'll come up again. I will use that. That's one of my favorite inequalities. Yeah.
Is that divisible by b minus n?
And that's the big deal. Anything like this can be factored. And here I'm telling you now, in fact, there's a problem on the worksheet that if you know that what the factorization of this looks like is much easier. This can always be factored as b minus a, right? Because we know a root of this polynomial is when b equals a. So b minus a must be a factor of it, right? So it's b minus a, and what's the rest of the factor? Now, if you guys don't remember this, it's cool, but it's b to the n plus b to the, or hold on, blah, 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 n minus 1, b to the n minus 2a plus b to the n minus 3, a squared, yada, yada, yada. B to the, what was that? Right. No, so yeah, there's going to be b a to the n minus 2, and then a to the n minus 1. Okay? I mean, and if you don't know this, it's cool. I'm telling you right now. But see, this is the kind of thing, like, I think I first learned this in, like, Algebra 2 in high school or something like this. And the reason is, that's one of the things that kind of is horrible about this class. That you are literally required, like, almost asked to remember all these little facts, like how to factor something like this. And it's not that we do it on purpose, it's just that we just want to get your mind jogging so you remember all these facts. So that things aren't as surprising later when I use them kind of arbitrarily. Does that make sense? But cool. So now, I haven't actually done anything. I've just shown you a nice way to write this. But we've already noticed, this already looks a lot like this. Can anyone think of a way to maybe like make that sort of look like this?
Multiply by n.
What's that?
Multiply by n.
So multiply by n, maybe. The problem is if I multiply by n, I have to multiply by n on the other side. So we don't want an n on the left. It's not that simple. And here's the first time I get to show you this very simple fact. Well, this already looks like what we want. How could we get this to look like what I want? Well, a is less than b. So it'd be very nice if I could just stick in b for this one. So, in fact, this probably isn't less than or equal, the way I've written it. If it's just two reals that are positive, then it's less than or equal because they can be equal. But yeah, the point is, notice that a is less than b. A squared is less than b. And the thing is, if you don't believe me, you can just check really quickly. If I have some, I know a is less than b. But what we said before, a to any power is less than b to any power. Right? By, I don't know, some lemma I proved somewhere over here. Oh, that guy, yeah. So that in general means, if I have a to the j times b to the, oh gosh, now I have to think. N minus 1 minus j, yeah. This is just less than or equal to b to the j, b to the n minus 1 minus j, which is just, so no surprise, b to the n minus 1. So great, maybe I'll say star, hold this star. Again, this is scratch work. This is not a formal proof. I kind of stopped doing the formal proof thing a little ago just so we can get through more. But when it matters, I'll put down some formal proofs here and there. But this is like what you're doing on your scratch paper before you write it up nicely. You figure, like, in fact, how would I write this up? I'd be like, just note that because of lemma 1, a to the j is less than b to the j, which tells us anything like this is less than this, and then I would just do the huge inequality after it. Make sense? That's how I would write it up. This is scratch work. I'm doing this now so you guys see how I thought it out, not